Okay, so in this video, I'm going to show you first how to lay out a color illumination system using OpticStudio, and then I'll talk a little bit about uh, my critics. I actually do have some. All right, so anyway, starting from scratch, here's a um, blank screen, and okay, a color illumination system needs two lenses, basically a condenser and a projector. So I am going to first choose my aperture stop as my first surface, and then I'm going to have my condenser have a 25 millimeter focal length. So what if I want a one-to-one projection of the light source onto the projection lens? Then I will just choose 50 millimeter for the object distance here, and then I'm gonna have the first lens, Paraxial lens. Um, let's call it the condenser, and let's give it 25 millimeter focal length. And then, okay, when I click on this menu, there's a scroll down menu which you cannot see because for some reason the video recorder that I'm using does not show this extra window. So I'm just going to tell you that when I click on the right side here, there's a drop down menu, and I'm going to select marginal resolve, and obviously it's going to give me 50 millimeters. And then I'm going to, the next thing is to, oh yeah, I'm gonna set my field size. So what if I have a 5 millimeter size source? Okay, semi diameter. Okay, so let's see what this looks like right now. It um, looks like that. Okay, good. Right, something like that, right? So my second lens is gonna be also a paraxial thin lens, and it's the projector. And okay, so this focal, I gotta choose a focal length now. What focal length should I choose? Well, if I want to project now, a color illuminator is such that you got a condenser projecting the source onto the projection lens. The projection lens will project the first lens, which is this condenser, onto the screen. So if I want to do that, then and I'm 50 millimeters away from the projection lens, then I would need to have this lens to be about a few millimeters in front of the first focal plane of this lens. So let's choose 45, right? 45, and then choose a chief ray solve. Why? Because I have a chief ray who is now at the object point of this lens, and relative to the projection lens, that's the object, right? So if I choose a chief ray solve at zero height, that will just bring the focus of the chief ray to the screen. So chief ray 0, 450, and yeah, there you go. That's your projection lens. Okay, add more rays, and it'll look like this. Excellent. Okay, so how do we prove that this really is a color system? To prove it, we're going to show that uh, um, if I have a light source like an LED in the form of the letter F, right here, I should not see the letter F on the screen because I'm projecting the first lens, right? So there's a nice feature here where you can simulate that. It's called the geometric bitmap analysis feature, and you can already see it's locally homogeneous because it's looking at the screen, which is the image of the first lens. But anyway, I'm going to choose something else. I'm going to choose letter F. See, this is the letter F. Field size, 5 millimeter size. So it's 10 millimeter in full size. The screen's about maybe this, 250 millimeters. One wavelength. Let us choose a false color plot. False color, interestingly, I am actually red-green colorblind, so I'm missing some red-green cones. I cannot distinguish very well between red and green. I can see the colors. In fact, if you tell me that a tomato is really, really red, I will eventually psychologically see it as really, really red. I don't know why it works that way. But anyway, okay, source. Source is Lambertian. Okay, it's going to be Lambertian. And let's choose 5 million 5 million rays. Let's choose less pixels so you can spatially we're kind of doing a moving average, and then interpolate the pixels. Why not? Right? Why not? So okay, so what do you see? All right, so you see a fairly locally homogenized distribution, right? If I choose instead of false color, I choose cross section Y. I see this slight dome. It's a slight dome because it's a cosine fourth distribution from a Lambertian source from the letter F to the first surface. Um, to prove that there is such a thing as the letter F being projected into the projection lens, let's choose a surface. Let's go back to false color. You see this distribution? Let's go. I'm looking at the screen now. The image is basically the last surface of the screen. What if I choose surface 3? Surface 3 is where the projector is, right? So surface 3, and what do I see? Oh, wait a minute. I gotta reduce the size because the projector is about 10 millimeter in diameter, right? So let's go 25, let's say, right? Okay. There we go. Letter F. There we go. Letter F. That's looking at that's placing my detector at the projection lens, right? And I can prove that I can defocus the letter F, right? I can say I don't put the marginal ray solve. I fix that. I defocus it 52 millimeters. Okay, 55 millimeters. There you go. It's defocus. Can I increase the pixel resolution? Okay, there we go. When I'm not defocused, it's sharp, letter F, at the projector lens, right? So there you go. If I go back to the screen, it's anyway, you've already seen that. Okay, so that is color illumination. So now let's talk about critics. The origin of this exercise is that every now and then, I mean, you don't see critics right now yet in the comment section of my YouTube videos, not yet. But in my career, I've had critics. Right? Who hasn't had critics? And once in a while, I might receive a private message from someone saying, "Why are you using OpticStudio for illumination? You should be using light tools. You should be using um, Trace Pro or some other program." Now, I don't have any problems with these programs. Those are programs that are excellent programs. They're magnificent. They work really, really well. But we choose programs for our work, right? And in my work, I've by default I started learning lens design through Zemax, and I just don't change. I don't switch because in my job I'm so busy. I have to deliver, and as soon as I deliver, I don't spend extra time looking at what other programs do and how to solve problems using other programs. I'm still using Zemax to do other work, or um, I'm following up with my colleagues after delivering my design. I'll talk to the manufacturing guys. I'll talk to other R&D guys, firmware, hardware. If it's a PCR instrument, I'm developing a real-time PCR instrument. I'm talking to everybody. I gotta talk to chemists, biologists, mathematicians, algorithm developers, firmware, everyone, right? So I'm constantly communicating. So I don't have time to quietly sit in my desk and try different software, different algorithms, and just bend rays. I'm not that kind of ray bender. I am a kind of ray bender, but not that kind of ray bender. And it's no problem being the kind of ray bender where you want to spend all day writing code and bending rays. But I'm just not that. I am an optical system ray bender, right? That's the first thing I want to say. But the other thing that I want to say is that there was one time an individual said, why if I were to use Trace Pro, he said this, if you use Trace Pro to lay out a color illuminator, it's very quick. Um, but I just showed you how I did it in OpticStudio. It's also really quick, right? It's not a problem doing it at all. And I can even use everything here is sequential ray tracing. It's not non-sequential, and I can still simulate the distributions of light. That's not to say that I wouldn't want to use the other programs in some way in the future. See, I'm a non-partisan ray bender. I would use any program that works. It just so happens that I'm using OpticStudio all the time, and I have to keep delivering and delivering, delivering. The other thing is, instead of spending time coding and looking at other programs, I also spend time reading a lot of books and also trying new things and coming up with new novel designs like the anti-zoom lens or a freeform lens that changes focus by moving a liquid crystal shutter up and down. Or some of you may have heard of me talking about the illuminator, right? The illuminator is a top hat a module that produces top hat illumination as on screen. And I will never be able to tell you how that's done because that's protected by a company. It's a company. It belongs to a company, even though I invented that. What I can say is that I did not use any special illumination design program to invent that illuminator. I did not use any sophistication at all to design that illuminator. I did not even use non-sequential ray tracing. I did everything in OpticStudio sequential mode, and before I did everything, I was by hand calculating uh, where rays should go. And I just go into the program. I went to the program and tell the program exactly where I want the rays to be. Because I know that when I put the rays there, it'll be a top light illumination profile. And then I gave the design to my colleague in Singapore, and he went to the lab, set everything up, tried it, and it worked the first time. It was so flat, the illumination was so flat that a customer even asked, "Are you sure you're not saturating the detector? It's so flat." Well, no, yeah, we're not saturating detector. We had an 8-bit camera, 0 to 255, and it was very far away from saturation. You could turn the current up and down. You can see the profile go up and down. So, what did Maverick say in Top Gun? Right? He said, "It's not the plane, it's the pilot." Right? No, I'm not trying to be arrogant and say hubris things right here, but basically, we do things for a reason. We use software that we are comfortable with. Oh, I gotta share with you guys also this one time. There's one time this one other individual wrote me a message and caught up with me and said, "Hey, yeah, I remember old times." And I said, "Hey, good job. It looks like you've done a good career. You've had a good career." And he wrote back, "Yeah, I'm working in a company designing world-class optical systems." And for some reason, out of nowhere, he just wrote and said, um, "And in order to design world-class optical systems, we must use software with a command prompt." He's telling me something, right? That he knows I'm using OpticStudio, and OpticStudio does not have a command prompt. Um, I, I don't know where that's coming from, right? Um, so if you're designing OpticStudio, use the optical systems with OpticStudio, it's not world class, I guess. I don't know, but I think that if you're comfortable using a program for your work, you gotta use it. Um, and if if you're good in what you do, just show your work, just show your stuff. You don't have to tell somebody else you should use this program because you suck. Actually, it's the opposite, right? It's not the program. It's the way of the Ray bender.